Welcome to Chapter 4, Lesson 4 on Scientific Notation. So starting off, we got some vocab. So standard form is numbers that do not contain exponents. Scientific form is a number that's expressed as a product of a factor and a power of 10. So for example, if we had 10,000 in scientific form, that would be 10, not even 10, correction, 1 times 10 to the 4th, because we're moving our decimal point over 4 places. And we'll get further into that as we go along. But scientific form is some number times 10 to some power. So converting to standard form. If the power of 10 has a positive exponent, you're going to move the decimal to the right, which means it's a really big number. If the power of 10 has a negative exponent, you're going to move the decimal to the left, which means it's a really small number. So for example here, 2 times 10 to the 3rd. That's a positive exponent, so we've got a decimal right here after the 2. We're going to move it to the right 3 spaces. So 1, 2, 3. Decimal, you fill in each space with a 0. So this is 2,000. 6.8 times 10 to the 5th. So you've got 6.8. We got to move our decimal over 5 spaces. So 1, 2, 3, 4, 5. There's our new decimal. Fill in with zeros. So we've got 680,000. Here, 3.25 times 10 to the negative 4th. So that means we're moving to the left. 1, 2, 3, 4. So our answer here is 0.00325. So you can go ahead and try these ones and check back with me, just making sure you're moving the proper direction. So 4 times 10 to the 2nd, move it over 2, so we've got 400. 5.94 times 10 to the 7th, so 1, 2, 3, 4, 5, 6, 7. Fill in all those zeros. It's a big one. 594 with 5 zeros. Put my commas in. So 59,400,000. Whew. Here we've got 1.3 times 10 to the negative 3rd, so we're going left. 1, 2, 3. There's my decimal. So 0.0013 is our answer there. Now we're converting into scientific notation. So if the number is big, you're going to have a positive exponent. If the number is small, you're going to have a negative exponent. So when you're converting into scientific notation, if you noticed up here in these ones, there's only a number in the ones place. Like here, 4, 5.94, 1.3, 2, 6.8, 3.25. So we can only have one number in front of our decimal. So doing this, I'm going to move my decimal point over 1, 2, 3, 4, 5, 6 places. So it'll be 4 times 10. I moved it 6 places and it was a big number, so it's just a positive 6. Here, I need to move my decimal point over 2 places to get it so that there's only one number in front of the decimal. Times 10 because it's scientific notation. It was a little number, so it's going to be negative, and we moved it 2 spaces. This is flipped around. So here we're going to have you try. Estimate each value using scientific notation. Correction, no we're not. So here it says the population of Kansas is 2,853,118 people. We want to write an estimation in scientific notation for the population. So first thing I'm going to do is I'm going to go, estimate. That means we're just going to say 3 million. right? We're going to make it the easiest number that we can possibly get. To write that in scientific notation, it's going to be 3. We're going to move over 1, 2, 3, 4, 5, 6 spaces, so times 10. It was a big number, so it's positive, to the 6th. Done. There's my estimation for Kansas's population. So then here, I want you to try and do an estimation and then check back and see if you got what I got. So here, 3,612,500. I'm going to go, we'll give it 3,600 because there isn't really a very pretty whole number to round that one to. So if I move my decimal, I'm going to need to have 3.6 times 10. It's a big number, so it's positive. I'm going to have to move it 1, 2, 3, 4, 5, 6 spaces. So 3.6 times 10 to the 6th centimeters. That's a lot. Here, we are going to have to get our decimal right here. So we'll have, let's round actually. So we're going to round this to be 3. We're still going to have to move our decimal all the way there. So we're going to have 3 times 10. Since it's a really teeny number, it's going to be negative, and it's going to move over 1, 2, 3, 4, 5, 6, 7 spaces, and add our label, feet. And finally, I'm going to round this to just straight up 4. And then that's already in scientific notation for us. So 4 times 10 to the negative 3rd kilograms. Easy as that. Now we've got some word problems. So here it says the space shuttle traveled at about 8 kilometers per second. At this rate, the shuttle would take about 4.5 times 10 to the 4th seconds to fly to the moon. Is it more appropriate for the newspaper to report this time as 4.5 times 10 to the 4th second, or about 12.5 hours? Explain your reasoning. So looking at this, 4.5 times 10 to the 4th seconds, I literally have no idea what that time even means. But I do know what 12.5 hours is. So 12.5 hours is the more appropriate way to represent this because it's a number that you can actually visualize, whereas 4.5 times 10 to the 4th seconds is such a huge amount of seconds that I can't even imagine how long that would take. So you try. It says a dime is about 5.875 times 10 to the negative 3rd foot in diameter. Is it more appropriate to report that diameter of a dime is that amount of a foot, or 7.05 times 10 to the negative 1 inch? Explain your reasoning. So our better option is this inch here, because this is such a tiny amount of an inch, it's even teenier amount of a foot. So it's more easy to visualize the inch, like the portion of an inch, than it is to visualize the teeny portion of a foot. So now we have comparing and ordering numbers. So to compare numbers in scientific notation, number 1, you compare the exponents. The bigger the exponent, the bigger the number. If you can't get them all ordered out from there, you go to number 2. So if they have the same exponent, compare their factors. The bigger the factor, the bigger the number. So here, their table shows different geological times and periods. Order the time periods from oldest to newest. So, first thing I'm doing, I'm checking the exponents. 8, 8, 7, 8. Okay, so our 7 is not as far away. So this one is our newest. So that's going to be number 4. Because I'm going to say oldest is 1 to newest is 4. That's a 1, believe it or not. Now we have all the same exponents. So we're going to have to go and look at their factors. So 2.8, 4.38, and 2.45. Right off the bat, I can go, well, 4.3 is way bigger, so that's further away. And then I've got 2.08 and 2.45. 2.45 is bigger, so it's further away. than 2.08. Come on, buddy. There we go. So now you try. It says approximately 1.372 times 10 to the 7th square kilometers of Antarctica and about 1.834 times 10 to the 6th square kilometers of Greenland are covered by an ice cap. Which landmass has a greater area covered by ice? So we've got these two numbers. I'm going to start off by comparing their exponents. And would you look at that? Right here, the 7 is bigger than the 6, so that area is greater. So that means Antarctica has a greater area covered by ice.